Good morning everyone. So today we will be reading about slow sand filter. So in the previous slide we have read about the theory of the filtrations, what are the process of the filtration. Okay. So as all of us know, sedimentation and screening, there are two water treatment process and it can be removed. This process helps to remove the large number of suspended particles, inorganic matter, organic matters, and the rest of the remaining particles, they can be removed by the filtration process method. So I have already discussed the four different processes, that is mechanical staining, flocculation and sedimentation, biological metabolism and electrolytic changes. There are the four processes already I have discussed in the previous slide. Okay, so now we will be discussing about the types of filters. So what are the types of filters? The filters are categorized into two types. First is gravity filters and next one is pressure filters. Again, the gravity filters are again categorized into two types. First is slow sand filters and second one is rapid sand filters. So today we will be now reading about the slow sand filters. So what are the purpose of the slow sand filters? In the slow sand filters, we will be reading about the purposes, essential parts and efficiency of slow sand filters, cleaning, working principle. We will be reading all this in the slow sand filters. Okay. So first, already I have been discussed the purpose of the slow sand filters. You can see here the diagram of the slow sand filter. This is here inlet, this is the outlet. Here the water is entering in this, and outlet where the water is flowing outward. Okay. We can say that the water is allowed to pass slowly through a layer of the sand which is placed above the base material. We can see here the sand is placed above the base material and which improves the biological, physical and chemical characteristics of the water. So now we will be reading about the essential parts of the slow sand filter. So what are the essential parts? First is enclosure tank. So enclosure tank, it is an open watertight rectangular tank made up of masonry or a concrete, and it is a waterproof material, and the bed slope of the enclosure tank is 1 in 100 to 1 in 200 and the depth of the tank is 2.5 meter to 3.5 meter. Okay, so next we will be reading about under drainage system. Okay, you can see here this is the under drain system. Okay. In the under drainage system, it consists of two parts. First is central drain and the lateral drain. So in the lateral drain, it is placed at a distance of about 2.5 to 3.5 meter. In between it has been placed. Okay. And the stopped at a distance of 500 millimeter to 800 millimeter from the walls of the tank. And it is the open joint pipes. This is all about the lateral drain. Next, we will be reading about the base material, that is gravel. So, it is placed on the top of the under drainage system. Okay, you can see here the diagram. The gravel is placed on the above the under drainage system. Okay, and it varies from 300 mm to 700 mm depth, graded and laid in layers of 150 mm. The size of the gravel in each layer should be bottommost layer, it should be 40 to 65 mm, intermediate layer, that is middle layer, it is between 20 to 40 mm, and we can say it as 6 to 20 mm it can be layered, and in the topmost layer it should be 3 to 6 mm. Okay, so this is all about gravel, that is the base material which is placed on the top of the under drainage system. Next we will be reading about that is filter media. Okay, filter media means that is sand, the sand layer which is placed above the gravel. Okay, you can see here the sand layer, the gravel which is placed above the gravel, it has been placed, the sand layer. The sand layer which is placed above the gravel, it is up to a depth of 600 mm to 900 mm, and the filter media size of the sand, it should be vary from 0.2 to 0.3 mm, and the coefficient of the sand is in between 2 to 3, and the finer the sand, the better will be the filtration. Okay. So next we'll be reading about the working of slow sand filter. In the working of the slow sand filter, as we can say that the inlet means the water will be entering through the inlet chamber. The water is allowed to enter the filter through the inlet chamber, and it purifies the water process, or you can say it descends through the filter media, and during this process the water gets purified. And these filters are usually worked for a maximum filtration head, that is 750 mm. Okay, this is all about the working of the slow sand filter. Next, we will be reading about cleaning. In the cleaning, the top layer of the sand is to be removed to a depth of 15 to 25 mm, and the effective depth of the filter media is to be reduced. Fresh layer of 150 mm depth of the graded sand is to be added. Okay, we can say that in the slow sand filter, the cleaning process would be the top layer of the sand, the top layer of the sand is to be removed to a depth of 15 to 25 mm is to be removed, and the depth of the filter media is to be reduced, and the fresh layer of 150 mm depth of the graded sand is to be added. Okay, and the rate of filtration means the 100 to 200 liter per hour per meter square of the filter is the rate of the filtration. And efficiency, what are the efficiency of the slow sand filter? We can say it as the bacterial load, that is 99.50 to 99.9% the bacteria has been removed, and in the color 20 to 25% of the color has been removed, and the turbidity, the 50 ppm, that is parts per million, it can remove. Okay, this is all about the slow sand filter. Next, we will be discussing about, that is rapid sand filter. As I have already told, filter have been divided into two types. Okay, first is pressure filter and gravity filters. Gravity filters is again divided into slow sand filter and rapid sand filters. Slow sand filters already I have discussed, and this is all about rapid sand filters. Okay, same we'll be reading about purpose, essential parts, we'll be all reading about that. So in the purpose of sand filters, rapid sand filters, the rapid filters are used primarily to remove the turbidity after the coagulation and flocculation in the large water treatment plants. Okay, this is the rapid sand filter diagram, and we can say that this rapid sand filter is used to remove the turbidity after the coagulation and the flocculation in the large water treatment plants. Next is we'll be reading about the essential parts. Same, the slow sand filters essential parts, same as the rapid sand filters essential parts. First we'll be reading about enclosure tank. It is of the smaller in size, and therefore it can be placed under the roof. Okay, and it is of a rectangular shape, and it is constructed of the concrete or masonry, and the depth of the enclosure tank is 2.5 to 3.5 meter, and the surface area is to 20 to 50 meter square. It's the surface area. Next, that is filter media. Filter media, that is I have told, that is sand. It should be free from any dirt, organic matter. It should be hard and resistant. The depth of the sand media, that is 0.6 to 0.9 meter, the depth should be present, and the effective size of the sand is, that is 0.35 to 0.6. We can take it as a common value, that is 0.45 also we can take it as, and the coefficient of the sand, that is 1.2 to 1.7. Okay, in the slow sand filter it was about, the coefficient was about 2 to 3. Okay, here we will take it as 1.2 to 1.7. So estimation of the sand depth. Okay, the depth of the sand bed should be such that the flocculation should not break through the sand bed, and the depth of the sand, it should be vary from 60 to 90 centimeter. And the base material, that is gravel, it's a depth of 45 to 60 centimeter, and the size of the gravel, each layer, the topmost layer it should be placed, that is 3 to 6 millimeter, intermediate layer, that is middle layer, that is 6 to 12 millimeter, and the bottom layer, that is 20 to 50 millimeter. And same under drainage system to collect the filtered water uniformly over the area of the gravel bed. And next, that is working. What is the working of the rapid sand filter? All the valves are kept closed except the valve A and the valve B. The valve A is open to permit the water from the clarifier, and valve B is open to carry the filtered water to clear the water sump. And the head of the valve, that is 2 meter over the sand bed, is maintained, and the filtration rate, that is about 3000 to 6000 liter per meter square per hour. And the filter run mainly depends upon the quantity of the water, and the filter run may range between the less than a day to a several days. And the objective of the backwash is to remove the accumulated particles on the surface within the filter media, and the backwash is performed using the wash water or air scouring. And what do you mean by backwash? Backwashing means filter is backwashed, and when the head loss through it has reached the maximum permissible, and 2 to 4% filtered water is used for the backwashing purpose. Okay, so rapid sand filters are also, we can say that it is washed by the sending air and water upward through the bed by the reverse flow through the collector system. Okay, so this is all about the rapid sand filters. Next, we will be discussing about the pressure filters in the next slide. Thank you.